So here's the steps for today. We're still going to be finding the event in the sample space and making a fraction out of them to find the probability, but the things we're going to be finding probability of, there's just so many ways they can occur. We have to use our counting rules to find the number of ways the event can happen and the number of ways the sample space can happen before we can do the probability. So let's go ahead and see what that looks like. Alright, number 1, or example 2a. It says you throw 3 dice. What's the probability that you roll all 3 sixes? Okay, well, probability. We have an event and a sample space. Now the event I'm looking for is the thing I'm trying to find the probability of. What am I trying to find the probability of? Rolling 3 sixes, right? So, and the sample space is the total number of outcomes that could happen when you roll 3 dice. So let's go ahead and look at the event first. How many dice am I rolling? And they're all 3 sixes. So how many options do I have for the first dice? If it has to be a 6 for the event, right? So if this has to be a 6, how many ways can a dice be a 6? There's only one way a dice could give you a 6. Because there's only one side that has a 6 on it. How about the second dice? How many ways can the second dice give me a 6? And the third dice? And all these are happening together, so we're going to multiply to get 1. There's only one way you could roll 3 dice and get all 6s. Okay? But let's look at the sample space now. Still 3 dice, but how many total outcomes are possible for the first dice? It could be 6 different numbers, right? And the second dice can be 6 different numbers, and the third dice can be 6 different numbers. Right? So we multiply all the way across and we get 216, and therefore the probability that you roll all 3 sixes is 1 out of 216. So that's the basic idea. Identify what your event and sample space are, use the multiplication tricks to find out the number of ways each happens, and then make a fraction. Alright, number 2. Number 2, event, sample space. Let's read it. Suppose you had a computer randomly organize the letters of the name Sue. S-U-N-E, you're randomly scattering those letters around. What's the probability that it will correctly spell Sue? What's the event? That it correctly spells Sue. So I'm going to put correctly spelled. Now, we're dealing with 3 letters, right? So, 1, 2, 3. Now, if we're correctly spelling Sue, then what has to come first? So how many options do I have for the first letter? 1 again, right? And if the second letter has to be a U, so how many options? 1 and 1. So there's only one way you can use the letters S-U-N-E to correctly spell Sue, right? Let's go ahead and take a look at the sample space. Now, for the sample space, we're still doing with 3 letters. How many possible letters can there be in the front here? 3, and then 2 left for the second space, and then 1 for the third. Now, we're not going to divide the order out because we're looking at how many ways we can arrange the letters S-U-N-E. If you divide the order out, you're not going to have anything left. So we want them to be arranged. So that's a total of how many ways to arrange them? And therefore, the probability that you're going to correctly spell it is 1 out of 6. Here we go. Letter C. Now, C and D get a little bit trickier. Suppose you have a jar containing 3 red marbles, 2 blue marbles, and 3 green marbles. What is the probability that you will pull out 2 greens? Alright, well, let's do our event and sample space. First of all, what's the event I'm looking at? Pulling out 2 greens, right? So the event that we're looking for is the event that you're pulling out 2 greens. Now, what's the sample space? The sample space is how many different ways can you just take 2 marbles out altogether? Okay, any 2 marbles, not just 2 greens, but any 2 marbles. So any 2. So here we go. Now with the event, we're just looking at the greens. How many marbles am I taking out? 2. And we're just looking at the greens. So how many options do I have? 3 greens for the first one and 2 for the second one. But I'm taking out a group, so I don't care about the order of these marbles. So this is what makes this problem different from the other one. I need to divide the order of the marbles out. How many ways can you arrange 2 marbles? 2 times 1, right? Leaving a total of 3 ways you could take 2 greens out of a group of 3. All right? Now, sample space. We're pulling how many marbles out still? Still 2. But what changes is I'm not looking at just the greens. I'm looking at all of them. Now, how many total marbles do I have? So for the first choice, there's 8 marbles. And for the second choice, there's 7 marbles. And once again, do we care about the order when we're pulling marbles out? No, not on this one we don't. So we divide by 2 times 1 again. 4 times 7 is 28. So what are the chances then that we're going to pull out 2 greens? 3 28ths. 3 and 28 chance. Not very good odds. Not very good chances. Okay, so let's go ahead and take a look at D. D's tricky too. Let's see why. You roll 3 dice. What's the probability you roll a 5, and a 2? All right. So what's the event I'm looking for here? The chances that I'm going to roll a 5, another 5, and a 2. Okay? And the sample space is all possible outcomes whenever you roll 3 dice. All possibilities. All right. Well, for the event, I'm only allowed to use what letters here, or what numbers? 5 and 5 and 2. Okay? So really, it could be dice 1 is a 5, dice 2 is a 5, dice 3 is a 2. Or it could be dice 1 is a 5, dice 2 is a 2, dice 3 is a 5. So in other words, I'm just looking at how many ways can you arrange those numbers, 5, 5, and 2. So how many dice are we dealing with here? 3. How many do I have to choose from? Which is a total of how many options? There's only 3 options there. So the first one could be any one of 3, right? The second dice could be any one of the 2. And the last one could be the last one that's left. Okay? So now we're going to do the sample space. How many total outcomes are possible when you roll 3 dice? Well, when you roll 3 dice, how many outcomes are possible for the first one? There's 6 numbers on the first dice. And on the second dice, how many options can happen? There's still 6 on that second dice, and on the third dice. And then, so let's see what we got. The top is 6 out of 216, and we can use our calculators to reduce that. And I think we would get 1 out of 36. Thank you. So there's a 1 in 36 chance of getting a 5, 5, 2. Okay? All right, moving along. Here's some for you to do.